There we go. All right. Well, hey, everybody. Welcome to the Weekly Space Hangout for Friday, April 24th, 2015. My name is Fraser Cain. I'm the publisher of Universe Today. And joining me this week, we've got an all-star special guest. We will get to at the end, just so we, keep you waiting. Oh, first, we've got Alessondra Springmann. Sandy.
Hi.
Hello.
Hi.
We've got Dr. Brian Koberlein.
Hello.
Man, am I the only one who's super excited? I'll just keep cranking this up. We've got David. David.
Hey, we're back in Florida.
Right on, with stable internet.
Yay, we're camping in our house.
That's awesome. Time to put your life back together. We got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
All right, and of course, and probably one of the reasons why you're here, we've got a special guest this week, which is Bas Lansdorp from Mars One. Bas, thank you so much for coming on the show.
Hi, Fraser. It's a pleasure.
All right. So, of course, we are going to spend quite a while talking with Bas about the Mars One project and sort of everything that's been happening so far, as well as some of the controversies. So, I'm going to be a real journalist today. So, just prepare yourselves. I know this is not something I do very often, but this is I got to do this. But before we do, I just want to remind you that this is an interactive show. So you can ask us questions and we will pass them along both on some of the stories that we covered this week as well as some questions for Bas, which is great. So to do that, wherever you're watching the show, just go and click where it says that we're interacting with the audience. Click that. You'll see the video, but you'll also see all of the questions that have been asked so far. Go ahead and vote for questions that you want to see, and I will be watching that regularly, and I will pass your questions along to our special guests, which would be great. So just to show, I'm going to say hi to Jason Carlson and Nancy Graziano and Andrew Planet and Lionel Ward and Bert Walters and Jim Meeker and Illit Avron and Hugo Burnham and David Dunn, Amanda Tesk, Stephen Hawkins, Ryan McDonald, Noel Ruppenthal, Sev Dustbunny, Will Adoni, and Douglas Crandall, and Guido Bibra, and Tony Lynch. So, big crowd of our regulars, which is great. So go ahead and go and get your questions ready. So, I've got a bunch of space news, blah blah blah. This week in Musk, the usual. But let's get cracking with our special guest. So, Bas Lansdorp, thank you so much for joining the Weekly Space Hangout. I know it's been sort of a pretty exciting time for you. For anyone who's been living under a rock and has no idea what the Mars One project is, can you give us sort of an overview of it?
Mars One is a not-for-profit organization that wants to establish a permanent human settlement on the planet Mars. Very different about our project compared to many other plans for Mars exploration is that we are proposing a mission of permanent settlement or a one-way trip, which means that the crews that we send to Mars are going to stay there, and instead of trying to do the almost impossible, trying to send crews from Mars back to Earth, we're going to keep sending crews every 2 years to really have a ever-growing colony on the Red Planet.
And I think I've done quite a few stories about this in the past, and the original NASA plan was like the Battlestar Galactica plan back in the 1980s to send, it was going to be like $500 billion, and then Bob Zubrin in the 1990s pitched this idea of the Mars Direct plan, which maybe could be done for more like $10 billion with live off the land, a much smaller infrastructure. But one of the missions sort of started as sort of people proposing this other idea was that why bring the people back at all? It's so much less expensive to just send humans on a one-way mission. So what do you think is the sort of the reduction in the cost and expenses of sending a mission when it is this one-way trip?
Well, actually, for me, it's not about expensive or even about technical feasibility. I think it's just more logical. I mean, there's a whole new planet to discover. We're spending hundreds of man-years every year discovering this Earth, and we're not nearly ready. So why would you send humans to Mars that want to go back? Just send people that want to stay there. It's just much more logical. But you're absolutely right. It's also a lot less expensive. It's a lot more technologically feasible. It has a smaller timeline. You can do it sooner than a return mission, and all these things make it easier to finance because you don't have the huge technology risks of the technology development, which usually comes with delays. The shorter timeline means that it's easier for investors to see the horizon on the return on their investment. So it's about those technology issues, and I imagine how difficult it is to do a return mission. It's difficult to launch rockets from Earth. 5 to 10% of all rocket launches end up with the satellite either exploded or in the wrong orbit, and that's from Earth with hundreds of engineers checking the rocket at the last moment. I don't see how we can do it at all from Mars without a huge support crew on the planet. So the risks of launching humans from Mars is maybe the most important reason not to do it, and I think that's the most important reason NASA hasn't done it yet. But I believe that the cost reduction is at least an order of magnitude compared to the return mission, which is roughly what we see. So we have a cost estimate of about 6 billion, and the lowest cost estimate of NASA that I've ever seen is about 65 billion. So it's roughly an order of magnitude. But I actually believe that a return mission would be a lot more expensive than that.
And when you talk about a one-way mission to Mars, I think for a lot of people that seems crazy to leave this planet and go to a place that that makes the coldest parts of Antarctica look like a tropical paradise, and it's very dangerous, and people would be on the edge of survival for the rest of their natural lives, and yet you got an enormous response, right? How many people have responded to the call for candidates?
About 200,000 people applied to our mission, but I was actually not so surprised because there have always been people that wanted to explore new regions. So far, it's always been here on Earth. But imagine how difficult it must have been for people in West Africa to decide to walk out into the unknown or to sail out into the unknown. And that was really the unknown. I mean, even in the time of Columbus, when he sailed across the Atlantic, he thought he was going to India. And that's only recent. I mean, that's only 500 years ago. He thought he was going to India, and he ended up in America. So back then, those people had no idea where they were going. So I believe that it's only natural that there have always been people that explored, and that there will always be people that want to explore. And Mars 1 is just the next logical step. Going to Mars is the next logical step of human exploration.
But when you're walking out of Africa, or you're hopping on a ship and you're attempting to cross some strait to the next island, you can get back to where you started with the technology that you brought along with you. But this is a situation where there is no way for these people to get back, and their very survival really depends on that the technology has been planned out properly, the mission is planned, the support arrives. And really, I mean, do you feel like the people are emotionally equipped, or that they've really made this decision understanding the depth of the risks involved and the consequences for what this means to be living on Mars for the rest of their life with their families, people they love, all of that?
Well, actually, you're pointing out three things. So the human aspect is really important, but I would like to first point out that technology keeps a lot of humans on Earth alive, and without technology, a lot of people on Earth would die. I mean, I live in Holland, and humans are not native to Holland. Without technology, I couldn't survive a March night, let alone a January or a December night. I mean, clothing is technology, housing is technology. That's all things that the ancient humans didn't have. So everywhere in the world we need technology to survive. And then, so the permanence is a very dramatic part of the mission, a very important part of our mission. But many humans have migrated to, for example, from Europe to North America, or from Europe to Australia, and never returned. They could return. Psychologically it's a big difference, but usually they didn't. And don't forget that they could not communicate. And when you were in Australia, it would take you 2 months for a letter to get to your parents, and then 2 months to get the reply from your parents back. So that's 4 months for communication. On Mars, they will never be more than 40 minutes away. So from that point of view, it's actually a lot less extreme than leaving your friends and family behind, even just as little as 100 years ago.
So what about the psychological effect?
Oh yeah, actually that was your actual question. So absolutely, I fully agree with you that that is a very big challenge for our project, and I actually believe it's a bigger challenge than the funding and the technology. For us to find a crew of 4 people, so we're not looking for the best individuals, but for the best crews of 4 people that can actually do this, that can leave everything and everyone behind, that can survive all the challenges of the trip, that can survive on the planet with all the really difficult situations that they will come into. That's one of our biggest challenges. And to make sure that we have those right teams, we'll train them and we'll test them here on Earth. So we'll build a copy of the Mars outpost where we lock them up every year for an undetermined period of time. So when they go in, they don't know if it's for 30 minutes or for a year. And we'll test them with all kinds of situations. They'll live under Martian conditions with all the communication delays, with the water restrictions, and we'll test them for their ability to survive as a team. And that will really prepare them for what they will prepare them as well as possible for what they're about to find on Mars. But of course, there is no real simulation of going to Mars, because it is really one way when you go to Mars, and that we can never simulate that.
So when you're calculating the risks of these things, I mean, obviously this is a high-risk adventure. What type of death rate are you estimating? In the sense of if you construct a building, for example, you do a skyscraper, you can estimate a certain amount of deaths per construction.
Yeah, we're not at such detailed levels yet that we can give actual numbers for that. So we're in the mission concept study phase. We have a number of mission concept studies performed, but also a number that have not been performed yet. So we can't really say it's X%. But I'm very sure that it's higher than the risk of climbing Mount Everest, which is about 2.5%. So 2.5% of the people that try to climb Mount Everest don't make it back alive. I'm also pretty sure that we need to keep it lower than the risk of smoking. So smoking is about a 15% chance of dying because of smoking, and I'm pretty sure that we'll have to keep it below that, because otherwise it's simply not an acceptable mission. So it will be somewhere in between those numbers. Otherwise we just simply can't do it, and we'll have to come up with a better design. But safety is very high on our priority list, so we'll land 8 cargo missions in the same technology as the humans. So before the humans go, we'll have tested that technology. When the humans land, they find a habitable settlement with everything in redundant. So full redundancy with additional spare parts and backup systems. And just a few weeks after the first crew lands, the hardware for the second crew lands. So they'll have even more hardware to make sure that they can at least survive. So safety is high on our priority list, but don't forget there is no safe mission to Mars. Actually, there is still no safe access to space. It's still very risky to go to space.
So keep somewhere in between pizza and cigarette smoking, somewhere in that.
Per year.
So you've clearly thought about this crew size of 4. Given the fact that we're talking about a non-trivial likelihood that a crew member perishes at some point during this trip, can a crew of 3 continue to effectively operate? I mean, that's a loss of a quarter of your capability. Do you think that a third or a half of the remaining people would be sufficient to survive on the surface of Mars?
Well, the crew of 4 is determined mostly by what we can do. Unfortunately, it's just impossible to send 6 people. So we'll train the crew with redundant skills, obviously. So especially medical skills, for example, will be everybody will be trained in that. Engineering skills. So at least 2 people will be able to do every single job. So in theory, it should be possible to have the colony survive with 3 or even 2 crew members if it's the right people surviving. And of course, we can't send immediate support, but we can send information. So if we need to send them additional training material for one of the other people, then we can still do that. But obviously the crew size is one of the risks. So the risk of something happening to someone.
Oh, Guess his internet.
We've lost a crew member.
Oh no!
Can we still function?
That was we can pull us through.
Hopefully I'll come back.
That was actually covered pretty well. I don't know if anyone read The Martian. You know.
I was gonna ask.
I was going to ask if you'd read that. Yeah.
Yeah. But in The Martian, right? They did a really good job of sort of showing how his survival was really dependent on the information he was getting back from Earth. They were helping him reprogram the rover to do better communications, and I can imagine if a person had a 3D printer, etc., then that would be great.
Yeah.
I guess
coming to a near you.
Yeah. I get so many questions. Oh well. But we can keep rolling. Why don't we talk
the
about
invite link again, maybe?
Yeah, well, he can just click the link again. But why don't we talk about something else while we're doing this? Happy 25th.
Want to talk about controversial other topics?
He's back. He's back.
Hi guys, sorry about that.
Well, your theory was exactly right. You dropped out, and we were able to maintain without you because we were sort of cross-trained in various skills of internet presenting.
It happens to everybody.
Yeah, it happens to everybody. Go ahead, David. I know you've got a question.
Yeah, I noticed in most of the Mars One artist conceptions, they're showing SpaceX hardware, and I wondered. I assume that's like with the Falcon 9 Heavy and the Red Dragon and things that are coming down the line in the next decade or so. And I wondered if there was any kind of official contracts with SpaceX or any other kind of organizations for the actual rocket that Mars One envisions using.
So the capsules look a lot like Dragon capsules, because back at the time when we started the conceptual art, we thought that we would be using the Red Dragon. I think right now that it's much more likely that we'll work with Lockheed Martin for the landing modules. We have already had our first contract with Lockheed Martin for our first unmanned mission, and we're very eager to start the contract on the larger landing system that we need together with Lockheed Martin. They simply have the most experience, and that's it's very important for our mission to use as much as possible existing capabilities, existing skills. So I think that at this moment it's most likely that we'll work with Lockheed Martin on that. We haven't sourced any launches yet because it's simply too early. We need to first have good designs of the hardware, know exactly what we want to launch, what the requirements for the launch are, so what vibrations can we accept, what kind of other requirements do we have for the launch, and then we can choose our launch vehicles and try to get the best supplier for it. So at this moment there's no contract with a launch company, but we have especially very good discussions going on with SpaceX. So I've been there a couple of times. They've been to our office to talk about this, but it's simply too early to buy a launcher, to buy a rocket.
So we've got some questions here from the audience that's watching. So this one comes from Ryan McDonald, which is that 2015 got off to a great start for Mars One with your announcement of the first of the 100 candidates in February. What kinds of events are we going to see this year?
Well, Ryan is one of those 100 candidates, so it's very nice of him to point that out. Well, there's a number of really exciting things that will be happening this year. We're very hopeful that we'll announce the location of our simulation outpost in this year. We've signed a very significant investment deal, but we're still wrapping that up. And so it's not really a done deal yet because it's only done when the money is in the bank. But it's looking very promising on that investment deal, and that will enable us to get back in touch with our suppliers to get all those mission concept studies done. So I hope that by the end of this year we'll have for every single component at least the mission financed, the mission concept study financed, and hopefully also the first results. And certainly by the summer of next year I think we'll have all the mission concept studies finished, which would mean that at that point we really have the technology basis for our mission laid out. So then we can start talking in more detail about the technology readiness levels of all systems, start talking about the risks, hopefully have a better estimate of the cost. So that financing round is extremely important for Mars One. Then we hope to have a deal with an international broadcaster before the end of this year for the documentary series around the astronaut selection, which will really help us to get more people informed about Mars One. It will not only be about the selection process, but also in general about Mars One. So informing people what does it mean permanent settlement, what does it mean for the technology, what does it mean for the people that are going, and I think that will really help significantly. I think those are the most important things that are coming up.
This comes from Sev Dustbunny, which is one of our regular viewers. What level of long-term support will Mars One expect to have to be providing the team on Mars, or by the time of launch, you expect them to be completely self-sustaining? And I think this is, it's one thing to all of the effort to get these people onto the surface of Mars, but the whole point is that then they're going to be on the surface of Mars, and it's like once you break it, you've bought it. How will how do you plan to keep this colony alive, literally, for the rest of the lives of the people involved?
I missed the very beginning of the question. What's the level of
long-term support?
Long-term support. Okay.
Yeah.
So every 2 years we want to send additional crews to Mars, and each crew we send the hardware for each crew ahead of the crew. So the hardware of the second crew is flying together with the first crew to Mars in separate transit systems. And as the community on Mars grows, it will become more and more interesting to not send things to Mars, but to send production capability to Mars. So, of course, we'll send stored food for the first humans to eat for the entire period until the next supply mission comes. But they will try to grow as much as possible of their food on Mars, such that at some point in time, we hope that we won't be sending food to Mars, but we're sending LED systems and other greenhouse equipment to Mars. And we hope to do that for more and more systems, such that they become more and more mass independent of the Earth. And at some point, of course, we hope that we'll only be sending computers and medicine to Mars. And also, at some point, of course, we hope that even that will be possible to build on Mars. But I think that will certainly be decades after the first human landing. So our business case is the major components of our business case are twofold. It's the media exposure. It's going to be the most exciting event of all times when humans land on Mars, and the Olympic Games, which is certainly not the most exciting event of all times. They have revenue of about $4.5 billion US per event. So we estimate the value of media exposure around the first human mission, including the first year on Mars, at between 5 and 10 Olympic Games. So just that can finance the follow-up missions for a long time. And then, of course, the follow-up missions will also be extremely interesting. Imagine selecting the third and the fourth and the fifth crew. So that's one part of the business model. The other part is intellectual property. So for every system that we develop together with our suppliers, Mars One will make sure that we co-own the intellectual property, and that will, especially in the longer run, start yielding revenues, for example, for growing food with less water and energy, very relevant on Mars but also on Earth, recycling, solar panel systems. So those revenue streams will make it possible for Mars One to keep funding the mission. And don't forget that at that time, we have a lot of fans already, but at that time there will be a lot more that will be donating to Mars One. I expect that people will have Mars One in their will, and depending on how wealthy the person is that dies, that can have a really big impact on the revenues for Mars One.
So, I mean, based on your sort of current estimates, how long do you think it is until the colony itself is self-sustaining?
It's really difficult to estimate with current technology. So it will take a very long time. But there's a lot of very interesting developments going on in 3D printing, for example, with more and more capabilities in those kinds of systems. Miniaturization of a lot of things. You can't miniaturize humans, unfortunately, so sending humans to Mars is always going to be very difficult because they will always breathe oxygen, they will always drink water, but we can minimize the systems around the humans that are required to keep them alive. And there's a lot going on, but it's very difficult to estimate how long it will take. I think if we can achieve survival without support from Earth, so maybe not producing all the medicine, not building all the computers that we need for a luxury life, but for survival, that might be as soon as 30 or 50 years after the first humans land, but it's really a ballpark figure. It's very difficult to estimate.
Right. So, but the point being that your plans include that maintenance for the entire duration that the people are there.
Well, for the entire duration is in principle indefinitely, because we keep sending additional crews. Humans will live on Mars and will die on Mars, but more and more will go there, and hopefully we don't know if it's possible to have children on Mars yet because of the lower gravity. But at some point, that is also something that a real colony should be able to do. So that should be indefinitely, but there's a good revenue model that can support those supply missions.
So I got one more question here, and then I think we're gonna have to let you go. So this comes from Ignatiy Romanov-Cherengovsky. What would be the legal role of a permanent Mars colony politically? Would they be considered a separate state, or more like a research base in Antarctica?
Certainly in the first couple of years it's going to be very much like space missions, actually. So we expect that either the launching state or the state that has the control over the mission, that one of those states will legally be the state of the people living on Mars. But I expect that at some point in time they're going to declare their independence. I hope that day is going to be a very big celebration. But these are all things that are really up to the people on Mars. Because even if they are under US jurisdiction or under Dutch jurisdiction or whichever country, what do we do if they don't listen? And what are we going to do? Send in the Navy SEALs? That's going to be very difficult. And once the Navy SEALs are there, they're actually part of the Mars colony. So maybe the interests of the Mars colony are then the same as the one of the Navy SEALs. So I think that it's going to be to a very large extent independent from the start, but officially it's probably going to be either launching state or the organizing state that will have jurisdiction.
Awesome. So I know you got a run. So I just want to let you really thank you very much for joining us for the Weekly Space Hangout. We know you're a busy guy and you've got a lot going on, and we really appreciate you taking the time and answering both questions from us here and also the people watching the show. Thanks a lot, Bas.
Thanks a lot, guys. It was really a big pleasure to be on the show. Thanks for all the nice questions.
Maybe come back in a year and give us an update.
Sounds like a good plan. Thanks.
All right. See you later.
Bye-bye.
So I would want to just make a big shout out to the WSH crew, the community on Google Plus that really helped organize that interview. So this community I now consider them the executive producers of the Weekly Space Hangout. So they're a really enthusiastic community on Google Plus. They talk about the stories that they want to have on the show. They talk about the guests, and they even now are reaching out and scheduling interviews for people to join us, which is why we've had such great people join us. So a big thanks to them. If you're interested in this community, go to I guess bit.ly/WSH crew. Do Google search for WSH crew. That's Weekly Space Hangout crew, and you can find this really active and enthusiastic community. I highly recommend it. So thanks, everybody.
And after not being here for months, it was really sweet to see all the comments in the Q&A app that Sandy's back.
Yay! Sandy's
I
back.
don't recommend doing grad school, and I don't recommend doing it while trying to get off steroids. So that was very sweet. Thank you, guys.
Have you got a piece of an asteroid for us yet?
Hold on 1 second.
No, I want a fresh one from space.
Speaking of that, Jeff Notkin and I are going to be doing Hangout-a-thon together from his meteorite headquarters on Sunday at 2 p.m. Central Standard Time during the Hangout-a-thon. That's noon Pacific Daylight Time on Sunday, and we're going to be at his Meteorite World headquarters. So I guess in Desert Tucson, Meteorite finds you.
That's awesome. Actually, I guess I should make a note about my involvement on the Hangout-a-thon as well. So for those of you who don't know, we are doing the third annual Hangout-a-thon, which is going to be on starting on Saturday at 8 noon?
8 a.m. I think.
8 a.m. Pacific, 8 a.m. Pacific, yeah.
Yes.
And we're going to go for 36 hours, and we're going to watch Dr. Pamela Gay go mad live on Hangout. But to support her, and we're going to pitch in and help out, and so I'm going to be running the show on Saturday night from I think 8 o'clock till 2 a.m. or something like that. I don't know, whenever I am needed. And I think we're going to do a special weekly space hangout that night. And I'm sure Morgan and I are going to do another astronomy cast. I think I just voluntold you, Morgan.
I think you did too. But Sandy and I are going to spend an hour predicting the future.
Awesome.
So if you have any future questions you'd like us to answer tomorrow, paste them somewhere, tweet them at me or Sandy, and we'll spend an hour tomorrow predicting whether Mars 1's going to land before or after anyone else gets there.
So there was this wonderful, there was this wonderful spoof of Uptown Funk that was SpaceX launch you up, and it's like, go to Mars, die on it. R.I.P. Elon Musk. For whatever reason, for copyright reasons, it was taken down, but like someone posted it earlier this week, I think Zenny did, and it was just like, grad school is awful, guys. Don't go to grad school. This is like the second time I've laughed this week.
Well, you should join us.
I saw this video of SpaceX launch you up, and if it comes back, I don't know if there's an archived version of it somewhere, but it's really brilliant. They make fun of Orbital, they make fun of Lockheed and Boeing, and they have dancing Shotwell, and it's pretty awesome.
No, there's no way on earth I'm going to run that on this video because I don't want to get taken down with that. With that copyright violation. Okay, so let's move on with some actual news here. So first, Morgan, let's talk about 25 years of Hubble.
That's right. 25 years ago today, the Hubble Space Telescope was safely ensconced aboard Space Shuttle Discovery as it lifted off on one of the highest orbital missions of the Space Shuttle era. And it deployed a somewhat broken Hubble into orbit, and 25 years later, Hubble's made more than 1 million observations, formed the backbone for more than 10,000 scientific papers, and seems to still be going strong. It's sort of difficult, Hubble is 10 days older than I am. It's sort of difficult to imagine a world before Hubble because any picture you see today of anything outside of the solar system is probably based upon Hubble observations. And so it's really shaped how we view the rest of the universe. And it's also changed how we understand the universe. When Hubble was launched, we didn't know how old the universe was, and therefore we didn't really know how big it was. And we certainly had no idea how dense with stuff the universe was. Hubble revealed to us that there's at least 200 billion galaxies out there. That's a lot more than we thought of just 25 years ago, and it's been on the forefront of looking for some of the first extrasolar planets, for studying the relationship between forming galaxies and black holes. Pretty much, if you could think of an area of astronomy and even planetary science, Hubble has revolutionized it. It made some of the best observations of Mars. It provided observing support for Jupiter and Saturn with Galileo and Cassini. It's made pretty much the only observations of Uranus and Neptune. It found moons of Pluto in support of New Horizons. Pretty much, Hubble has changed the way that we look at our world. It's changed the way that we do science in the astronomical community, and it's come a long way since the fact that it was out of focus. And some people were saying, could this be the end of NASA 25 years ago? And today, NASA's going strong, and Hubble's turned out to be one of the most valuable scientific instruments that we've ever constructed.
Anyone here not love Hubble?
I'd like to mention too, Fraser, from the southern U.S. and southern Europe, you can see Hubble here in Florida. I see it a couple times every week. A lot of people don't realize that you can actually see it in orbit. It's actually pretty bright too. It actually flares like an iridium satellite if the sun catches the panels just right. But it's kind of interesting to see. And we're right at that latitude where it was launched from here, right around 29 degrees north, where it makes frequent passes every week.
So do you think we'll have a happy 50th anniversary, Hubble?
I think we're hoping to have a happy 30th anniversary for Hubble. If we can get to 30, that'll be a big step because that means it'll overlap with the James Webb Space Telescope, which will allow us to do a lot of calibrations and establishing a continuous sort of baseline of observation between today's premier space telescope and the future's, which is James Webb launching hopefully in 2018. But James Webb will be covering the infrared part of the spectrum, not the visible part, which is the primary area of light covered by Hubble. And I've seen a lot of people sort of fretting about the fact we're going to lose all these beautiful space pictures when Hubble goes away because there won't be a major optical telescope in space. And I just want to reassure people that those Hubble pictures are like 99% fake anyway. And so you're going to get just as great, if not much better, pictures from James Webb that'll allow us to see all sorts of things in quite literally a different light than we have for the last quarter century.
All right. Well, we spent so much time with Bas that we got to keep rolling. So it feels weird to quickly brush off the 25th anniversary of such an amazing observatory, but that's what we're going to do. So thanks, Hubble. Here's to another 25. Brian, dark matter interaction scene.
Oh,
sorry.
did Sandy want to go first?
Oh yeah, go ahead, Sandy.
Before we move on, Maya Weinstock, who does the Hubble minifigures, as well as a lot of other great space outreach, she wanted just to comment on this anniversary of Hubble that we should do a shout out to amazing astronomer and NASA leader Nancy Grace Roman, and she's the so-called mother of Hubble, but she's out of commission from an injury, so she couldn't attend this Hubble symposium this week. So if you just, everyone want to say thank you, Nancy Grace Roman, we can send this link to Maya later, and she can send this to Nancy Grace. So
thank you, Nancy Grace.
Thank you, Nancy Grace.
Okay.
All right.
Let's. That's awesome. Let's move on.
Okay.
Brian.
So dark matter. One of the big things with dark matter has been trying to figure out whether or not it interacts with itself. We know it doesn't interact much with regular matter, and we know it doesn't interact with light. But the question has been, does it interact with itself? And the way we have typically studied interactions of dark matter is looking at colliding galaxy clusters. So two clusters of galaxies come in, and what happens is the gas and dust will interact and will kind of stay in the center. You'll get star production and things like that. But the stars, because they're just little dense points like grains of sand, just pass right through. And the dark matter does pretty much the same thing. It will pass through the collision. And so when we've looked at collisions before, we've seen the effects of dark matter, but we haven't seen any interactions of the colliding dark matter. And part of that is because most of the places where we look for colliding dark matter are actually large clusters. So you have a whole bunch of clusters coming together, kind of like a big pile-up, and the dark matter goes through. Well, recently what they found is a galaxy cluster called Able 3827, and this is a small group of just 4 galaxies. And because it's just 4 galaxies, the collision is actually slower. So you get more time for the things to collide, and you get more time for the dark matter to continue on. And so what you can do is you can compare how far the stars have gone through the collision versus how much the dark matter has gone through. And in this case, they've actually seen a difference. So what they're seeing is some type of interaction between dark matter. It is not completely, I wouldn't say transparent, it's not completely oblivious to each other, which is a big deal.
What form is the interaction taking?
That's what we're not sure about. The thing is that the idea that they're seeing is that it's probably some type of force that is not part of the regular ones. So one of the candidate models is called dark photons. So it would be an electromagnetic dark photons.
Is it April Fool's today?
No, I'm not. I'm not kidding. It is basically, if you assume that dark matter interacts in a similar way to electromagnetism, then what you get is the interaction that agrees with the model. It's very speculative at this point. I mean, the thing is, they're seeing some difference, so they're seeing some interaction. And there's a couple of models that it works with, but there's going to be dozens of other models that they come up with.
But when you say that they're seeing, where are they seeing? Are they seeing, particles coming from that direction? Are they seeing light in a certain spectrum? Are they seeing how are they seeing dark photons, whatever that even is?
Well, no, they're not seeing dark photons at all. What they have is a theoretical idea of dark photons, and the distribution of dark matter agrees with it, but it would agree with a lot of things. So
the I'm trying to understand this. So the distribution of the dark matter, the way the dark matter is like piling up around the galaxy cluster, is providing some evidence that it's interacting, but they're not seeing any
what you
outcome.
see is two galaxies come together, the stars just zip right past each other, and so the gas and dust kind of collides, but the stars just zip right past each other, because the stars basically don't interact.
Yeah.
They're so small, they just have near misses or anything at all.
Which is good news for us when we collide with Andromeda.
Exactly. Yeah. So the dark matter, in most collisions, what we've seen is it go exactly with the stars. So as the stars basically don't interact, the dark matter doesn't interact, and they both go together. In this particular case, what they've seen is the stars have gone completely through like they would. The dark matter is a little bit behind. The dark matter isn't going quite the same way. And so that's evidence of some type of interaction of dark matter colliding with dark matter.
We got to get ahead of this dark photons word. There's
a dark force to it.
This is a dark force to it. All right. So Dave Dickinson is sharing something.
Yeah, this is from the folks at the Virtual Telescope Project. This past Monday, we had a 15-meter asteroid 2015 HT1 pass. A little closer, a little further away than geosynchronous orbit. It was about 20% the distance from the Earth to the Moon. And I thought it was kind of nifty. They did this little animation here of the passage. It's this little looping animation. You can see the asteroid right there in the center of the field. It was about 10th magnitude at closest approach, and you got the stars trailing by it. It was in Corvus, in the constellation Corvus, when it was on its closest approach. And I can see some satellite trails in the images there flash by too, but it's kind of nifty. They're going to do another broadcast on April 29th of asteroid 2015 HT10, which is going to pass 1.7 lunar distances away. But it's kind of nifty that they're doing these sorts of things.
Did we all die?
No, we lived through this one. We get these kind of passages a couple times every year, so they're always kind of nifty
once again.
Well, that's good news.
Yeah.
All right.
I'm always looking at the orbits to these too. A few of these have turned out to be returning space junk from heliocentric orbit. There's been a few cases of Apollo hardware that's been picked up. So I'm always kind of looking at these orbits for the right velocity and the right inclination for something that could possibly be returning space junk. But this is most likely a rock.
But this is one of the situations where it came out of nowhere, right? We didn't have any... we had no announcement. It was just, oh, by the way, here's an asteroid. It's going to get really close, and there it goes.
Yeah, the Catalina Sky Survey, and there's a bunch of key surveys that are generally out there looking. This was discovered a few days prior. A lot of times, and this shows the ability to find these, a lot of times we hear about these discoveries after they passed. So, like Chelyabinsk, we discovered that the morning it came through the atmosphere. So.
Fantastic. Okay, so let's move on then. Next up. Sondi, I don't actually know what you're going to be talking about.
I'm going to be talking about, did you get the link I sent you, about the 30-meter telescope project in Hawaii. So there's been some controversy around this telescope. If this has been getting hotly debated in various professional astronomer communities about proceeding with construction for the 30-meter telescope. So there's a Smithsonian article. I don't know if you got that one. Let me put it back. So the gist of it is that for the past couple of years, there's been this project to build a 30-meter telescope, and they were discussing sites in Chile, they were discussing sites in Mexico, and discussing sites in Hawaii. There are already a lot of telescopes in Chile. Having telescopes in the southern hemisphere is a good thing, and they're going to be building more big telescopes there. Building a telescope in Mexico would be great. There are some really good sites for putting telescopes there, but it's sort of a chicken and the egg problem. There's not a lot of telescope infrastructure. There's no telescope infrastructure in Mexico where they want to put this telescope. There are no roads. There's no fiber optic cable going up the mountain. So putting a telescope in Mexico means a gigantic infrastructure investment from someone. Is it going to be the Mexican government? Is it going to be the telescope program? And then finally, the other good place to put a telescope is Hawaii. Mauna Kea is almost 14,000 feet tall. The ocean, it's a very smooth mountain, so the ocean air goes very smoothly over the mountain, and so that you don't get a lot of instability in the atmosphere. The atmosphere doesn't shake around, so it doesn't blur your images as much. So your images from night to night are very consistent, or from hour to hour, minute to minute, are very consistent in how they get blurred. So Mauna Kea is a fabulous location. There are already a dozen or so telescopes up there, including arrays of telescopes. There's an established road, there's established staff, there's established internet connections going up there. So it's a really good place to put a telescope. However, the reason that we astronomers like putting telescopes there, also there's another reason people respect the mountain, is the native Hawaiian population. In their tradition, Mauna Kea is a sacred place. For some people, when the Polynesians first came to Hawaii, Mauna Kea was the first part of the Hawaiian island chain that they saw. It rises very high above the ocean. It's white. It's very distinctive. And so for Hawaiians, it's a sacred place. Some Hawaiians will bring the umbilical cords of their children up there so they can be close returned to the spirit world. There's rocks up there that represent various aspects of Hawaiian religion that are sacred to Hawaiians. So when people start building telescopes up there and start sort of ignoring some of the Hawaiian tradition and what Hawaiians consider sacred, there's going to be conflict. And so there have been protests in the past over the last at least couple decades. There was a really long LA Times article explaining some of the controversy from 2001 about building telescopes on Mauna Kea. And here in Arizona, we've had similar issues with astronomers wanting to build telescopes on Kit Peak, which is in the Tohono O'odham Nation. And so there's strong agreements about how many telescopes can be built. Every time a telescope is built, you have to take down an old telescope. So there's a conservation of telescopes. Tohono O'odham crafts are sold in the gift shop on Kit Peak. There's a real strong effort to have members of the Tohono O'odham Nation who live on the reservation working on Kit Peak, and a lot of outreach to people in the Tohono O'odham Nation to help them learn about STEM. So right now there are a number of protesters in Hawaii who are saying that the 30-meter telescope stands for too many telescopes. They're tired of telescopes going up on Mauna Kea. They're tired of having their sacred sites ignored or desecrated. They're tired of feeling like their concerns are ignored. The people who support the 30-meter telescope say, oh, well, we went through everything legally, we went through all these processes correctly, we involved people, we had town halls, and some Native Hawaiians would say, well, your laws don't necessarily apply to Mauna Kea. This is our land, this is our sacred land, it belongs to our gods. You can't just come up here and do as you please. And there was a quote from the LA Times article says, you know, scientists are used to getting their way, and so cultural sensitivity sort of vexes them. So there's been a lot of been reading a lot of emails that have been going back and forth. Someone referred to the lying hordes of Native Hawaiians who are protesting this project, which, as you might imagine, has set some people off. There's a lot of sentiment from the astronomical community that, oh, we'll just get past these protests and we'll keep construction going, which I think also does not ingratiate them to members of the Native Hawaiian population who are protesting this telescope. So there's a lot going on here. There's a great Smithsonian article on it. There's an LA Times article on it. I encourage you to go out and read about this because it's an issue, and if we're going to keep building telescopes in areas that are sacred to the folks who were there first, we're going to have to, as scientists, develop a little more cultural sensitivity and not get used to having our way.
In other news, Canada came on board and contributed our portion of the money to the telescope. So,
right, I saw all these emails. It was sort of funny. I saw a bunch of tweets from Canadian astronomers who are usually very sensitive to issues of indigenous people and native populations. And they're like, oh, great, Canada's on board, as all these emails are going around about the protests against the 30-meter telescope. And so I thought it was a very interesting contrast that people are really excited for this telescope, but also they sort of forget what telescope construction means.
Well, it's not necessarily, I think, forgetting. It's about being committed to the science, putting in our money to build a new telescope, and whether it gets built in Hawaii or whether it has to get built somewhere else, we've committed the money.
Well, I think part of the money from the Gordon Moore Foundation, the Moore Foundation, means it's going to have to be built in the U.S. And if you look at the initials for TMT, that also could be 30-meter telescope, but it could also be the Moore telescope. So I think that's part of why they chose those initials. So I mean, yes, it's really exciting that Canada has committed money to this, but I think there's also some desire that folks are sensitive to the cultural issues around construction on Mauna Kea.
Yeah, and you're absolutely right. It's as a Canadian, I can tell you, it's something that we come to grips with all the time. It's a big part of the conversation for the kinds of projects that we do here in Canada. So, I hate to shorten this, but we've literally got like 5 minutes left, and there's a pile of stories here. So, I'm going to run through these remaining stories very quickly, and we're not going to get through them all. So, but Morgan, we've got a jet on 67P.
Yeah, that's right. This is an amazing pair of images taken by Rosetta, 2 minutes apart. One of them, they see nothing on sort of the rear part of the duck, and 2 minutes later they see a jet more than 900 meters long coming out. This is going to allow us to really estimate the velocity and transit patterns of particles coming off of comets for maybe the first time.
Mm-hmm. Excellent. Let's move on. Dave Dickinson, 2015 Lyrids are coming up.
Yes, they actually passed Wednesday. We had a zenithal hourly rate of about 20. They arrived a few hours later than predicted, which isn't unusual for a meteor shower. And there was no outburst this year. The last time we had a big outburst from the Lyrids were back in the 1980s, I think 83. There was a zenithal hourly rate of about 250. But it's always worth watching, and this is usually the first good shower of the year. I was out Wednesday morning. I saw a couple while I was waiting for Hubble to pass over, so no major meteor shower from this one this year, but it's always worth checking out.
Brian Koberlein, they've potentially solved the CMB cold spot mystery. I don't know if we're going to
the cold spot is, well, the cold spot is there's a small region of the cosmic microwave background that appears cold while surrounded by something warmer, and it's statistically unusual. And because of that, there's been a lot of speculation, among some theorists that maybe this is evidence of some, parallel dimension or external cosmic something or other. And this latest work has actually found that the cold spot can be explained by a very large void in the cosmos, that basically there's this gap where there aren't any galaxies, and what that does is it makes the cosmic microwave background look colder in that region than it actually is. It's called the Sachs-Wolf effect.
And so the calculations that they've done match what we see in the observations?
What they do is it reduces the anomaly from statistically interesting to just well within the odds.
Morgan, the Japanese are going to land on the moon.
They plan a soft robotic landing on the moon in 2018 if they can get additional support from the Japanese government. This would make them the fourth nation after the Soviet Union, United States, and China to land on the moon, although India is also planning to land in the 2018 timeframe.
Ganbatte kudasai.
What'd you say?
Good luck.
Good luck in Japanese.
Do your best. Bear down. Struggle through difficulties.
Struggle for the cause. Okay. So I think we should probably wrap things up since it's 1 o'clock by my clock. So first, I would like to once again thank the good folks at the WSH crew for really being our executive producers for this show, organizing some of the special guests. I know there's more coming up, and we really appreciate your help. We couldn't do this without you. How exciting was that to be able to talk to Bas Lansdorp? That was awesome. So remember WSH Crew? Just do a search for that on Google+. Morgan, were you going to be answering people's questions, or is that going to happen on the Hangout-a-thon?
Yeah, well, why don't we defer that till the Hangout-a-thon. Tomorrow, Sandy and I will be on at 6 p.m. Eastern Daylight Time. That's 3 p.m. Pacific. I believe that's 20 hours GMT. We'll also have a special weekly space hangout tomorrow as well. So plenty of time for, we covered a lot of stories today, cover a lot of questions tomorrow.
Absolutely, yeah. No, hopefully we can get through a lot of those stories that happen. We can just sort of freeform it. Maybe get some people who this is a tough slot for them to be able to show up on a regular basis. So,
and Morgan and I are a lot of fun when we're goofing off together.
We've seen it. Brian, what does it say on your blackboard there? I see it says adv. Is that Adventure Time? What does that say?
Adventure. That's a long story.
Okay. So let's wrap things up. So, Sandy, where can people find out more?
I'm on Twitter. I'm on Twitter as @Sandy. And apparently, since changing my profile to say an execrable agent of destruction and cats, I'm getting a lot more followers.
Is it the destruction part or the cats part?
I'm not sure.
Dr. Brian Koberlein, how do people find out more?
You can find me on Twitter at Brian Koberlein. You can find me on my website, briankoberlein.com, which is one universe at a time. This weekend, you can see me at the CosmoQuest Hangout. I think at 1 p.m. is when I'm going to be on. And then coming in June, you'll be able to find me in Chile for a week. I'm going down to see a whole bunch of telescopes. So
lucky.
Lucky me.
Lucky you. And of course, you've got a podcast, so people should, in addition to the One Universe at a Time, they should go and subscribe to your podcast and listen to people argue about various scientific topics.
That's right. That's right.
Sandy is completely destroying the cat. Dave Dickinson, where do people find out more? Oh, we can't hear you. You can go at AstroGuys with a Z. He probably wrote for Sen.com, for Universe Today, for Canada.com, and on his own website. So check
How about now?
Yeah, now we can hear you.
Oh, yeah. I also got a new article up for Sen this week on the commissioning of advanced LIGO and the hunt for gravitational waves. They're going to be starting here later this year, so that's kind of cool. And I'm going to be a one-man virtual star party for CosmoQuest Sunday night at 8 p.m. Eastern Daylight Time.
Fantastic.
If I can find my scope.
It's right behind you. It's right there. Morgan, where do people find out more?
You can find me on Twitter at Morgan Rehnberg, or you can visit my website, morganrehnberg.com.
He has a really nice website.
Yeah, absolutely. So just one final reminder to everybody, if you want more of the space goodness, have all you can handle starting tomorrow morning for 36 straight hours, where all of your favorite people and your future favorite people will be singing for their supper to help raise funds for CosmoQuest, to help sort of keep the organization rolling. So in advance, I thank you very much for participating and for donating and contributing. We really appreciate your help. We literally cannot do this without you. So if you feel like having the level of space education and outreach and support that we bring into this universe is important to you, then join us during the Hangout-a-thon and help contribute and help donate to keep all these projects going. We really appreciate your help. So, once again, I'm Fraser Cain, F. Cain, on Twitters and all the other places. So, so glad you were able to show up and join us in the show today, and we'll see you all tomorrow.